Inside the king's chamber of the Great Pyramid, a single granite sarcophagus sits without a lid, its interior hollowed from one solid block. No seam, no joint. The walls of the chamber around it are built from 43 granite slabs, the largest weighing close to 70 tons, each one quarried 600 kilometers south at Aswan, and dragged, floated, and lifted into position. With a flatness tolerance modern stonemasons still struggle to match using power tools. Granite sits at an 8 on the Mohs hardness scale. It is harder than the iron tools that existed at the time. It is harder than most steel. The accepted explanation, taught in universities and printed in textbooks, is that workers pounded the stone with dolerite balls and wore it down with wet sand and copper saws, acting as guides rather than cutters. That explanation accounts for roughness. It does not account for what is actually on the sarcophagus walls, straight parallel cut lines, evenly spaced, cutting deeper on one pass than copper or dolerite should physically be able to achieve, in granite without curving, wandering, or stalling. The marks are not consistent with pounding. They are consistent with something dragged through the stone under continuous controlled force, something with an edge that did not dull. In the next several minutes, you will see what that edge actually left behind. What a Victorian-era survey measured, but never explained, and why one fragment of hieroglyphic text, catalogued, photographed, and then quietly set aside for over a century, names the thing that did the cutting. If forbidden ancient history fascinates you, hit subscribe. Every week we decode what Egyptologists won't translate publicly. But here's what makes this stranger. The earliest detailed measurements of the sarcophagus and the chamber's granite joints were not taken by a mystic or a fringe researcher. They were taken in 1881 by the British engineer and surveyor, who is still considered the founder of modern Egyptology's measurement tradition. Working with calipers and surveying instruments inside the Great Pyramid, he recorded saw cuts in the granite running to a depth that, by his own calculation, would have required a cutting edge harder than any metal known to have existed in the Bronze Age. Pressed into the stone with roughly 2 tons of continuous downward force. He published the measurement. He did not have an explanation for it, and said so plainly in his own notes. That observation sat in the official literature, cited occasionally, explained by no one, for more than 100 years. The second piece does not come from Giza. It comes from a fragment of administrative text recovered at Saqqara in 1862, catalogued by the French archaeologist who excavated the necropolis, and now held in storage at the Egyptian Museum under a reference number that does not appear in any public exhibition guide. The fragment is part of a larger quarry record, the kind of document Egyptian scribes used to track stone shipments, crew assignments, and tool allocations. Most of it reads exactly like what it is, an inventory. But 3 lines near the bottom of the fragment use a phrase that does not appear in any other surviving quarry record. The phrase is wedjat-shesep, roughly, the eye that opens the way. It is paired with a determinative normally reserved for tools that rotate or strike repeatedly. And it is followed by a measurement notation Egyptologists have never been able to fully resolve, because the unit it describes does not correspond to any known Egyptian system of weights, lengths, or volumes. One quarry record, one unidentified unit, one phrase that exists nowhere else in the corpus. This is not speculation built on a vague carving. The fragment exists. It has been photographed. It has been read by credentialed Egyptologists who have, without exception, classified the phrase as obscure or untranslated, and moved on to the parts of the record they could explain. The inscription, read as an operational document rather than a poetic one, breaks into 3 parts. First, the tool. The determinative attached to wedjat-shesep is the same one used elsewhere for the bow drill and the rotary stone borer, implements that spin. But the scale notation beside it specifies a diameter far larger than any handheld drill, paired with a second glyph indicating two operators positioned on opposite sides, holding something steady rather than turning it by hand. That detail matters. A tool large enough to need stabilizing from two sides is not a hand tool. It is a fixed mechanism that something else drives. Second, the abrasive. The fragment lists a paste, ground fine, fed continuously at the cutting point, consistent with what modern materials analysis has actually found in the quarry residue at Aswan. Crushed corundum, a mineral rated 9, on the Mohs scale, 1 full point harder than the granite it was used to cut. Corundum is what modern industry still uses in grinding wheels today. The Egyptians had it, ground it, and fed it into something. That much is physical fact, confirmed independently of the inscription. Third, and this is where the text stops making sense, is the power. The unresolved unit appears directly beside a verb form used elsewhere only to describe the turning of mill wheels and the churning of river water by current, never used for human effort. Whatever wedjat-shesep names, the scribe who wrote it was reaching for a word that meant force applied continuously, automatically, without a person behind it. And then he used a unit of measurement that exists in exactly one place in the entire surviving Egyptian written record, this fragment. What the sarcophagus walls show under modern inspection lines up with that gap precisely. Geologists who have examined the cut faces under magnification report something the dolerite pounding theory cannot produce. The subsurface crystal structure directly beneath each cut line shows almost no fracturing. When you strike or grind granite with a harder material, the impact sends microscopic cracks downward into the stone below the cut. It is unavoidable, the same way wood fibers tear beneath a snapped branch. The sarcophagus cuts don't show that. The boundary is clean. The crystal lattice just below it is intact, as if the stone parted rather than broke. There is exactly one cutting process known to modern engineering that produces that signature. High-frequency vibration at the cutting edge, well above what a human arm can generate by hand. Disrupting the granite's crystal bonds faster than a crack can propagate. It is the same principle behind ultrasonic cutting tools used in modern manufacturing, and it requires a sustained, mechanically generated vibration, not muscle, not a swinging arm. Something closer to a driven mechanism running continuously at the cutting face. The dolerite and sand explanation cannot produce this signature under any laboratory replication that has been attempted. Every attempt to replicate the sarcophagus cuts using only Bronze Age hand tools has produced visible subsurface fracturing. The original cuts have none. The geographic spread makes the gap harder to dismiss as a one-off curiosity. The same signature, clean parting, minimal subsurface fracturing, a consistent advance rate per pass, localized point source heating, has been documented not only at the King's Chamber and the unfinished Aswan obelisk, but on granite casing fragments recovered from the Valley Temple at Giza attributed to the builder of the Second Pyramid, and on column bases in the inner sanctuary at a temple complex in Upper Egypt built more than 1,000 years later. Different reigns, different centuries, different quarries supplying the stone. And yet the cut signature on the oldest examples is the cleanest. By the time later dynasties were producing their own granite work, the marks had changed. Rougher, less consistent, closer to what dolerite pounders and copper-guided sand actually produce in controlled modern replication. Something was lost between the earliest granite work and everything that came after it, and whatever it was, never returned at the same level of precision again. The linguistics compound the problem rather than resolve it. Egyptian administrative scribes were meticulous about consistency. A scale unit, once established for one category of goods or labor, gets reused across centuries of quarry logs, ration lists, and construction accounts, because consistency was the entire point of the bureaucracy. The unit attached to wedjat-shesep breaks that pattern completely. It does not match the standard cubit-based measurements used everywhere else in the Saqqara archive. It does not match the weight notations used for stone shipments in the Old Kingdom. A philologist who reviewed the fragment in a 1994 academic paper described the unit as without precedent in the corpus, and proposed, without much conviction, that it might be a scribal error. A measurement unit invented in error and then used 3 separate times in careful, deliberate sequence, within the same short passage, is not a satisfying explanation. It simply replaces one mystery with a smaller one. What modern engineering actually knows about ultrasonic machining sharpens the stakes here rather than softening them. The process requires a transducer capable of converting some input energy, almost always electrical, into mechanical vibration at a sustained frequency above the range of human hearing, then holding that vibration steady at the cutting face for as long as the cut takes to complete. No ancient civilization anywhere on the planet has produced an artifact identified as a power source capable of generating and sustaining that kind of output. Not in Egypt, not in Mesopotamia, not in the Indus Valley. The output exists in measurable, photographable, peer-reviewed form, sitting inside a tourist attraction visited by thousands of people every week. The input that produced it does not exist anywhere in the archaeological record of the ancient world. That asymmetry, a confirmed result with no confirmed cause, is the actual unsolved problem here. Not a claim about lost civilizations or hidden technology, just a gap between what the stone proves happened and what nobody has ever been able to explain. Modern attempts to settle the question by simply trying to reproduce the marks have not gone the way the standard explanation predicts. Stoneworking experiments using dolerite hammerstones and wet quartz sand on Aswan granite samples, conducted under controlled conditions and documented on video, do successfully remove material. They also reliably produce the expected subsurface fracturing, a slightly uneven advance rate, and a rougher boundary than what survives on the sarcophagus and the unfinished obelisk. Switching to copper saws with sand as an abrasive slurry, the traditional explanation for the straight parallel lines, produces straighter cuts than hammerstones, but at a far slower rate, and still leaves the same telltale subsurface cracking the original cuts do not show. Even modern diamond-tipped rotary tools run dry against granite, leave more surface heat scarring spread across the contact zone than the tightly localized thermal points found at the original cut edges. The one variable that consistently narrows the gap in laboratory replication is vibration frequency. The higher the frequency of the cutting action, independent of the hardness of the material doing the cutting, the cleaner the parting and the less fracturing propagates downward. That is not a controversial finding. It is basic materials science, confirmed in machining literature having nothing to do with Egypt. What remains controversial is only the question this script keeps circling back to. What, 4,000 years ago, was generating that frequency, holding it steady, and feeding it continuously into a granite block for as long as it took to hollow out a 70-ton sarcophagus? That is the part no replication experiment has solved, because replication experiments test technique, not power source. You can demonstrate that a given frequency produces a given signature in granite without ever explaining what produced the frequency in the first place. Every modern test confirms the how. None of them touch the why. There is no surviving evidence of a why at all. What the standard museum placards leave out is what happened to the people who tried to look closer. In 1956, a structural survey team requesting permission to take core samples directly from the sarcophagus interior. Non-invasive, calibrated, intended only to measure the depth of subsurface stress, was denied access on the grounds of preservation risk, despite proposing a technique with no contact beyond a handheld gauge. The request was renewed twice in the following decade, denied both times, with no technical justification entered into the public record. In 1978, the same fragment containing wedjat-shesep was pulled from a planned exhibition on Old Kingdom quarrying techniques, after a museum reviewer flagged the unresolved phrase as potentially misleading to general audiences, a note that survives in the exhibition planning file, though the fragment itself was simply removed without further explanation and has not been displayed publicly since. Before that, the erasure ran deeper still. Around 1336 BCE, in the religious purge that followed the death of the pharaoh who had broken with Egypt's traditional priesthood, monuments referencing construction knowledge attributed to those who came before the first kings were systematically defaced across multiple temple sites. A documented historical event, separate from the granite question itself, but one that removed an entire category of inscription referencing pre-dynastic builders before later scribes had the chance to copy or preserve it. In 391 CE, the Great Library and attached archive at Alexandria was burned by a mob, taking with it a catalogued but now lost section of technical manuscripts the ancient librarians had filed under construction and quarrying methods. We have only the catalog description. The manuscripts themselves never resurface in any later text. And in 1817, a section of the official French survey of Egypt covering interior measurements of Giza granite structures was quietly dropped from the survey's second printed edition after appearing in the first. The missing plates are still listed by number in the index. The plates themselves are simply absent from every surviving second edition copy. There is a fourth layer running through the permitting authority that controlled access to Giza and Saqqara excavation sites for most of the 2000s. Between 2002 and 2011, any research proposal touching on pre-dynastic construction methods or unconventional toolmark analysis faced delays that routinely stretched past a year, with preservation risk cited as the standard justification regardless of how minimal the proposed contact with the stone actually was. A formal request to reopen the 1956 sarcophagus survey using updated, fully non-contact equipment was filed in 2007. It was still listed as under administrative review when the permitting authority's tenure ended in 2011. The request was never formally denied. It was also never approved. It simply stopped being processed. Now, here's where it gets current. In 2021, a European University materials science team applied to conduct a non-contact laser surface scan of the sarcophagus interior, the same kind of survey already used routinely on other ancient stone artifacts worldwide, intended to map microscopic surface texture without touching the stone at all. As of this recording, the application remains listed as pending. No scan has been conducted. The surface that could finally confirm or rule out the ultrasonic cutting signature beyond dispute has not been measured with modern equipment in over 4 decades. Now, let me be clear about what this is and isn't. I am not telling you the ancient Egyptians had electricity or that aliens built the pyramid. The inscription does not describe anything we can fully translate, and nothing here proves a specific power source existed. What it does show is a measurable gap, a cutting signature in the stone that no replicated Bronze Age technique has matched, and a single fragment of administrative text naming a tool and a force in language that appears nowhere else in the Egyptian record. We can describe precisely what process the stone proves happened. We cannot identify what powered it. That gap has sat in plain sight, in a published 1881 survey and a 1862 quarry fragment, for well over a century. and almost nobody outside a small circle of measurement-obsessed engineers has ever asked the obvious question out loud. The sarcophagus is still there, lidless in the king's chamber, its cut lines exactly as clean as they were when first measured in 1881. The Saqqara fragment is still in storage, still uncatalogued for public viewing, still carrying a phrase no scholar has fully translated. The unfinished obelisk is still lying in its quarry bed at Aswan, showing the same impossible precision right up to the point where the work simply stopped. The laser scan request is still sitting in a review queue somewhere in Cairo. Whatever cut that granite worked at a level the rest of Egyptian history never matched again. Not before, and never quite the same way after. The stone has been holding the answer in plain sight for 4,000 years. So far, almost nobody has been willing to look closely enough to read it.